We got two projectiles. One, we're just going to drop. It's going to hit right there. The other one, we're going to give a horizontal velocity, and it's going to follow a path that looks something like that. And we want to know which one, call this number 1, this number 2, which one hits the ground first. Okay, we ready? So keep your eye on it. This one's going to hit right here. This one's going to hit where? Right about here. 3, 2, 1. Good? Two objects, 1 and 2. And one, they both are given a horizontal velocity only. So the first one follows that path, and the second one is given a bigger horizontal velocity, and so it follows this path. So this will be, we'll call this 1, and this 2. And then at some time, when they're halfway down, 1 is over here, and 2 is over there, right? All right, so at the instant shown here when they're halfway down, how do the horizontal velocities compare? Compare the vertical velocities. Check with your neighbor, see if you got the same thing. I'm also going to ask you to compare the horizontal acceleration and the vertical acceleration. How do the horizontal velocities compare? Well, maybe we should do 3 first. How do the horizontal accelerations compare? They're the same. And what are they? So how do the horizontal velocities compare? V2, what did I call it? Horizontal? x greater than v1x, because they haven't, that's how they started out and they haven't changed at all. And how do the vertical accelerations compare? And what are they? Okay, and how do the vertical velocities compare? Same? Because they both started out with the same vertical velocity, 0, and they both had the same acceleration, and they both traveled the same distance, so they're going to be the same. Just like what we did here. Okay. Velocity versus time. And we'll make that, what should we make that? How about x? V sub x versus time. And then we'll do v sub y versus time underneath that. What are you using as your positive directions? Up and to the right? Should we do that so everybody gets the same graph, or? Okay, up and to the right are positive directions. So object 1, x, what is it starting out at? It's v sub x. Maybe here. And does it change? Something like that. Horizontal line. How about object 2? It starts out more, right? Horizontal line. Is that right? It's got 2 has a bigger horizontal velocity than 1 does. Both in the positive direction, both constant. There's no acceleration in that direction. Okay, how about for the y velocities? What's the initial y velocity for object 1? 0. And it's increasing. It's going faster and faster in the negative direction, right? So that means it's going to end up down here somewhere. How about object 2? Starts out at 0 y velocity, ends up some negative 1, 2, 4, 5. Should be the same value, right? Should look identical to the first one. Their y motions are exactly the same.